Hey everyone, we're Group Hehe C, and today we'd like to share with you our findings on the Cheater Teacher dataset. For Task 1, our goal was to find the cheating teachers. To do this, we had to find a way to identify these teachers without recklessly jumping to assumptions. We would expect a student's smartness, which is reflected by their yearly scores, to differ from student to student. Thus, we decided to separate the data into the unique classes taught by each teacher. We would then compare the score the student got with that teacher compared to the mean score the student got for the other remaining classes. This way, we are comparing the students with themselves. We call this difference the residuals. If the residuals were greater than 2 standard errors of the student's mean score, then we would deem this teacher a cheater. As you can see in this graph, there is a clear divide between cheating and honest teachers. After some manipulation, we see that there are 242 cheating teachers. 42 were from Year 3, 54 were from Year 4, 48 were from Year 5, 43 from Year 6, and 55 from Year 7.
Although we know the cheating teachers, we also know that not all students in their class have altered scores. A portion of results from cheated teachers will look just like the results from everyone else. Our approach to Task 2 was to find the distribution of the altered scores from the cheating teachers. We first separated the data into the honest teachers and the cheating teachers, and find the residuals for each set. We obtained the cheating residuals by subtracting the students' scores for the year they had a cheating teacher with the mean of their other scores with no cheating teacher. These residuals would represent the distribution of both the altered and unaltered scores of students from cheating teachers. Next, we would find similar residuals for the students who only had honest teachers across all 5 years. To do this, we simply take the scores a student obtained across all 5 years and subtract them with their mean score. These residuals are visualized using some density plots. We see that the residuals of the honest scores is normally distributed. We are able to calculate the mean and the standard deviation from this distribution. The residuals for the cheating scores, however, has an interesting shape. This is because there are 2 separate distributions in this data, one for the scores the cheater teacher alters and one for the unaltered scores. We can model this distribution using the following equation. Here, our 2 distributions are for the altered and unaltered grades for cheating teachers. Using a maximum likelihood estimator, we are able to estimate Q, mu1 and sigma1, which represent the probability the cheating teacher alters your score, the mean, and the standard deviation of this distribution, respectively. We use another function to obtain confidence intervals for our estimates.
From our final model outputs, we would expect that a cheater teacher would alter between 76.5 and 77% of student scores in their class. We would also expect that the average altered scores to be somewhere between 7.36 and 7.47 marks higher than the student's average score. The cheating teachers thought they were slick by altering the student scores in hopes to get that pay rise. Fortunately, Group Hehe C caught their sussy behavior and found out their cheating mechanism before it was too late.